Assalamu alaikum, dear student. This is Wajid Ali Shah, and today we are going to explain the topic AVOmeter. AVOmeter or multimeter is an arrangement enclosed in a box which can measure the current, the voltage, and the resistance of the circuit by the use of this same compact system. A is used for ampere, V for volt, and O for ohm. So AVOmeter or multimeter is a compact circuit enclosed in a box which can measure the current, the voltage, and the resistance with the help of the same instrument. So, it is an instrument to measure the current, voltage, and resistance. It is ampere meter, this one, voltmeter, this one, and ohm meter, this one. And because of these symbols, it is given the name AVOmeter. It can measure direct as well as alternating current and voltages. It is a galvanometer having a series of the combination of the resistors all enclosed in a box. It has different scales graduated in such a manner that all the three quantities can be measured. It has its own battery system for its function and for operating of the electrical circuits. Consider this circuit. This is one potential of the battery, one terminal of the battery connected here. This is the remaining circuit in which this is a voltmeter, this is an ammeter, this is an ohm meter, and all these three are connected in a circuit like this. So, for example, if we want to measure the voltage, we will set this knob, this key, we will connect this key to the voltmeter. Now, in this situation, the voltmeter is included in the circuit and ammeter, ohm meter are out of the circuit, so they are not used, and voltmeter is used to measure the voltage. Next, if we want to find the current, we will just connect this knob, this key, the second key, to the ammeter circuit, and the voltmeter circuit will be out of the whole circuit. So, in this manner, we can measure the current of the circuit. Now, if we want to measure the resistance of the circuit, we will just connect this knob to the ohm meter. Now this ohm meter is included in the circuit, and rest of the two voltmeter and ammeter are out of the circuit, and we can use this ohm meter to measure the resistance of the circuit with the help of this AVOmeter or multimeter. This topic is given on page number 136. Okay. Next, to explain this, for example, we take the current measurement system of this multimeter. For the measurement of the current, the selector switch is turned to X2. In the previous diagram, let me show you. This is, for example, X1, X2 and X3. So this is X1, X2, X3. X2 is connected to the ammeter, so that's why we will explain it here. In this diagram, this is switch X2. For the measurement of the current, the selector switch is turned to X2 in order to measure the current as in the previous diagram. The proper scale is selected. This circuit is a series combination of the shunt resistance R1, R2 and R3. These three are shunt resistances. They are of different values to find the current to different ranges. Okay. Any one of the shunts can be used for the measurement of the current in different ranges. This circuit provides a safe method of switching between current ranges without any danger of the excessiveness. This is one terminal of the battery connected here, this one. For example, this is high potential of the battery. Another potential is low potential. So, if we want to measure the current between R1, R2 and R3, we will simply connect this key to this point. Or if we want to change the range, the limit of the current which is to be measured, so we will simply change this terminal, this connection, and will connect it to this one. So in this manner, this gives us one range of the values of the current, this gives us additional further range of the values of the current, and this gives us an additional range of the values of the current. Okay. Next is voltage measurement. If we want to use the multimeter for the measurement of voltage, to make a voltmeter, we simply add high resistances in series to the galvanometer, and we can have the diagram like this. Galvanometer, one resistance, 2, 3, and so on. This is an on button, and this is one terminal of the battery, say for example negative terminal, and this is positive terminal. This is one point, this is another point, and this is another point. For example, this knob is connected to this positive terminal. If we want to find the voltage of this circuit, so we will add this one. We will simply connect this positive terminal to this, and the current will be flowing through the galvanometer like this. The circuit will be completed, and this volt or voltage can be measured with the help of this ammeter. If we want to change the range of the values, we will simply reconnect this terminal to this one. So now this time this resistance will be included in the circuit, and it will be acting like for the measurement of the voltmeter voltage like this. Say for example, if we want to change to measure the voltage of some higher values of the voltage, so we will connect this knob positive to this terminal, and now these two resistances will be included in the circuit, and we will have different range of the values for the voltage measurement, and so on. Okay, now it is the resistance measurement. For resistance measurement, we will have another circuit, a very simple circuit like this, a battery, one point, and resistance, another point, another terminal. For resistance measurement, the selector switch or the knob uses the circuit as shown in this figure. This is a very simple circuit. The leads are connected across the resistance to be measured. For example, this is the resistance which is to be measured. Let us suppose. The battery of the meter applies current to the meter for deflection, which in turn varies with external resistance and can be calibrated. In this case, the AVOmeter battery supplies current to the galvanometer for deflecting its coil. Since the amount of the current through the galvanometer depend upon the external resistance, we can calibrate the scale in ohms. The amount of deflection on the ohm scale indicates directly the magnitude of the resistance. The ohm meter reads a scale regardless of the polarity of the leads, because polarity of the internal battery determines the direction of the current through the galvanometer. Very important, let me tell you. For example, if we keep this circuit open circuit means that no current is passing through this circuit. So current is zero in this circuit, this moment, and we call this zero current as maximum resistance or infinite resistance. Infinite resistance to the flow of the current because there is no current flowing through the circuit. If we connect these two keys, so current will, now the circuit is called a closed circuit and the current will be starting to flow through the circuit. And by having variable values of the resistance or the current, we can calibrate the scale. For example, like this. We will have basically two scales. One for current. If the current is zero, so that time the resistance is maximum. If the current is maximum, so that time the resistance is having some different value or minimum value. Increasing current gives us decreasing values of the resistance. So in this manner, we can set a scale which can explain the resistance measurement of the circuit. Thank you. Have a nice day.